Hello, my name is Sen. I'm going to be trying to explain this problem to you guys. I don't never really done a problem explanation before, but I was just thinking since me and my friends had problems on this physics problem and we couldn't find any videos, why not just make one? So, this problem took me and my friends over a couple hours to figure out, and the help of the professor that teaches this physics class. For this homework, we do it on Wiley Plus, which I don't know why we do it on Wiley Plus, but we do. So, if you guys look up here, you can see that in figure A particle of charge, positive Q, produces an electric field of magnitude E point at point P. At this distance R from the particle in figure B, that same amount of charge is spread uniformly along a circular arc that has radius R and subtends an angle theta. The charge on the arc produces an electric field of magnitude E arc at its center of curvature P. For what value of theta in degrees does E arc equal 0.7 E part? Hint, you will probably resort to a graphical solution, which this hint is actually useful as we do resort to a graphical solution. But first things first, we can only go ahead and answer one of these problems. So, can I move this? No. Well, you see, it only gave us the units. The units are in degrees, so that's half the points right there. But, so, um, first things first, I have to explain what this problem actually is asking for. Ooh, I forgot how bad it is drawing with a mouse. Okay, never mind. I'm just going to type this out. So, we have E. That's not what I'm going to do. We have E arc. I'm just going to do it like that. We have E arc, okay? Nah, I'm going to do it with the mouse. Okay, so first things first, we have E arc equals 0.7 E part. So basically just doing what this guy up here is, this thing, right here. Okay, now this is a really bad writing. I don't know how to really write in this that well, but I'm going to go ahead and write out the definition of E arc and E port. So E arc is defined as 2Q sine theta over 2. Okay, I think I'm getting the hang of drawing with mouse. Over 4 pi. I'm pretty sure this is Coulomb's constant, but it doesn't actually matter what kind of constant it is, as these all cancel out. And I don't really know how to explain most of the theory, because the theory kind of just fell apart after a while. So I'm just going to explain how you arrive to your solution that me and my friends took like an hour to do. And our professor helped us figure out in the very end. But you see, you have your 0.7 or this is your different value. This is the only value that changes, is this. Everything else should be the same. The theta over 2 should be the same, the r squared should be the same, everything else should be the same. It shouldn't change. But E part, actually no, E part is not equal to 0.7, as I just said. That is the part that's different. But you have Q over 4 pi, the root E again, that thing. I drew it badly, but it's these two are the same. R squared. Okay? So now you set these two equal to each other. There we go. Control C, Control V, bam, bam. Okay, so you set those equal to each other, and then you put your 0.7 value right there. So you might be able to see that a lot of this stuff just cancels out. That all cancels. You have a theta 2q and q. You divide q by q, and that cancels. And then you're just left with 0.7 times theta, because you carry that over. So you take 2 sine theta over 2 equals 0.7 theta. So you might be thinking, how can you solve this? Because in reality, you really can't. But you might remember that it says to result to a graphical solution up here. So all that you want to do is just plug this in as two different functions. Y equals 2 sine theta over 2, and y equals 0.7 theta. So if I go back over here, I've already done this. You might have to put an x because you can't really do theta in Desmos. But then, so you're basically not looking at that, and you're really not even looking past 4. So, well, I mean, I'm not looking past 4. You could be looking past whatever, so I'll put that back at 10. But you see, there's only 2 points of intersection. 0, 0, which will give you nothing, and this point right here. So, let's say I took a picture of this really quickly, and I go back, that is OBS, I go back to notes, and I post this in here, and I move it up, I move it up here. Okay, so now you have that value. All you need is this value right here. So you can take that 2.82-ish, and then you can times it by 180 over pi. Because remember, this is actually in radians, and it's asking for degrees. Sorry for the very messy handwriting. As I said, I'm drawing with a mouse. But if I was to do this, which I might just go back to Desmos to show you guys how to do this. Desmos. Get out of Desmos. Desmos Scientific. Leave. Let me go back into full screen. Don't want you guys stealing my data, all my precious data. I take 2.82 times 180 over 2. No, over pi, not 2. Why did I put 2? I don't know. Where is pi in this? There he is. See? And now you have 161.57, or at least I do, with my value of 0.7. Your value will be different depending on what you have. But you take this, and that is your final value. This guy right here. This is it. I should not blow that up that much. There you go. That is it. You have this guy right here. So I have this little nice little answer sheet up here. So since it's in sig figs, well, it's not really in sig figs because, well, I guess no. The only 2 sig figs, or the 2 up top of 0.7, but you know, I can still put 162 degrees, which is my final answer in my chapter plus thingy. Right there, right here. That's it. So, I'm gonna go back to the notes and let you guys just look at it, so that you guys actually know what to do. Thank you guys if you actually like this. We're gonna probably keep doing these because why not? I'm bored. I did finish most of my work for the week, and I'm just goofing around. I will probably still be playing games, but just because I like playing games. So, remember, you start off with this. This is number 1. You go down here to number 2-ish. You cancel out your equation. This is your different value, and this is your different value. You have to graph these. Graph. That's a really bad way of spelling. Well, not spelling, but writing graph. And that's your third part. And then you have to convert it into radians, which is your fourth part. And then your fifth part is your answer and degrees. And that's it. That's all you gotta do. This looks like the crazy portion, writing in red everywhere. But, that's how it is. So thank you guys, and I might do another one of these, I might not, I don't really know. Bye.